Hello everyone, thanks for tuning in. I'm Yukesh and welcome to my channel Operations Panda. Please like and share the video, and if you are new to this channel, don't forget to subscribe the channel for more videos on operations management. Our today's session is on critical path method. Critical path method is basically a project management tool which can be used in Six Sigma 2 for planning your Six Sigma projects. In project management, critical path method is sequence of activities with no buffer or zero float, we can say. For example, if you have an activity which can be completed in 4 days, but even if you complete in 6 days, so it's not going to affect your total project timeline. So that means it has buffer or a float, but some activities don't have any buffer, like they are to be completed on time, or if they are delayed, the project will be delayed. So critical path method is a tool which helps project manager to identify all such activities or set of activities in project which lie on critical path. Once you identify those critical paths, you can deploy your skilled or more experienced people on same path, so that all those activities are handled in more professional way or someone takes care of. So let's begin with understanding few terms which are necessary in critical path method. So as you can see, ES, D, EF, LS, F in given table, those are terms which are very necessary to understand before we jump to critical path method. So what's ES? It is earliest time at which activity can be started. Now second is D, that is duration. Duration of activity. Like if you take some activity needs 4 days to complete, that means the duration is 4 days. Next is EF, that is early finish. Earliest time at which activity can be finished is called early finish time. Activity can finish in 4 days, or if delayed, it can finish up to 6 days. So early finish is 4 days. LS, that is late start, the latest time at which activity can be started without delaying a project. That means sometimes activities may start later, like they won't start in early start time due to some support reasons like purchase of delivery from your vendors or availability of manpower. So it can be delayed, but late start is a time which is late than early start, but it does not delay your complete project. So that is called as late start. Next is float. Float is difference between early finish and late finish. That means early finish time is like if your activity is going to complete in 4 days, but you may also complete in 6 days without delaying complete project. So 2 days buffer which you get, that is fourth day to 6th day, is nothing but float of 2 days. That is buffer which you have for that activity without delaying your complete project. So remember this diagram. Based upon same diagram, we are going to understand how critical path is determined. So let's begin with the sample project. Here we have a sample project which constitutes of various activities. Activities name are given here, that is A, B, C, D to up to P. In next column we can see predecessors. Predecessors are those activities which are to be completed before starting that activity, like B is completed before starting C. That means C depends upon activity B. For example, if you want to paint a wall, then painting is activity C, but activity B is preparing the surface or preparing wall surface. So until and unless you complete preparation of wall surface, you cannot start with painting the wall. That means activity C, that is painting, depends upon activity B, that is surface preparation. So respective days or duration required to complete every activity is also given here. So let us see how CPM or critical path method is applied on this project. Our first step for CPM is arranging those activities in sequence with respect to given information in this table. As you can see, A, B and F are those activities which have no predecessor. So they are opening activities, or they can be started on 0th time. As you can see, for activity D, A is predecessor. That means D follows activity A. Therefore, D comes after A. Similarly, for G, D, E and F are predecessors. Therefore, G is followed by E, D and F. Okay, these three arrows you can see. In this way, we have arranged all these activities. So this becomes our first step for CPM, that is critical path method. Now our second step is, or you can say, this upper factors like early start, duration and early finish. So let's see, for activity A, that is it can start on first day or 0 time we can say, and it needs 4 weeks duration to complete. So here we have given 4 and 0 plus 4 is 4 though. So early finish time is 4, that is 4th week this activity will be completed. Similarly, as D follows activity A, D will start on 4th week and it requires duration of 10 weeks. So it will be completed in 14th week. Similarly, G follows activity D. So G will be started on 14th week. So simultaneously, we will also see B, C and E, as in given information or in given table, B is predecessor of C. So C will start after B is completed. So B early finish time is 6th week. Now C will start in 6th week. Also it requires 5 weeks of duration. C will be completed in 11th week. Similarly, E has its predecessor as C. So E will follow activity C and hence it will start in 11th week, whereas it requires duration of 2 weeks. It will be completed in week 13. In case of F, it requires 3 weeks and it has no predecessor, so it has started on 0th and it will complete after duration of 3 weeks. So as you can see, G is followed by E, F and D, but here E gets completed in 13th week and F gets completed in 3rd week. So we will consider here highest, that is D. D is completed in 14th week. The earliest time of G will be 14 because it cannot start earlier than this day as it follows D also. So considering 14 as early start for G and 10 weeks of duration, it will be completed in 24th week. Similarly, H, I, J, all these activities are filled with duration and early finish time. After giving input of all these upper factors like early start, duration and early finish, now our third step is to fill this lower factors, that is late start and late finish and hence float. So first we need to determine which is our last activity. As we can see, after filling all these factors, we can observe that K is our last activity which completes on 46th day. So to fill this lower factors, we will start with end activity, that is activity K. So as activity K is last activity, that means our project completes with activity K. So we won't delay this activity because we need to finish this project by 46th week. So as K is last activity of this project and it completes in 46th week, so we cannot delay this activity, because if we delay this activity, our complete project will be delayed. Hence our late finish will be 46th week itself, and hence we have zero float. Similarly, we will get 45th week as late finish date. As we have zero float, we have no buffer for late finish or late start. Similarly, it will be followed by second last activity, that is P, J and N and so on. So as you go on filling these activities, what you will understand is, so calculating all those below factors, what we get to know is some of our activities, like in this case, we know that D has taken lot of time and hence we can delay activity E as we get buffer in these both activities. So E, C, B and F have buffers, that is E will have buffer of 1 day, whereas F will have buffer of 11 days. Hence we can determine our critical activities or critical path in this project, like all the activities with zero buffer or zero float is critical path. So in this case, A, D, G, H, I, J, L, N, O, P and K, this becomes our critical path. This is how we can determine critical path by this critical path method. But this is a conventional method, and these days no one use this lengthy method to identify the critical path. Rather, people prefer using many software tools like Microsoft projects. We will see how critical path method can be determined using Microsoft projects. Let's first get introduced to interface of Microsoft projects. So we are in Gantt chart view. On right hand side you can see a Gantt chart, whereas in left hand side you can see a provision for giving input to the Gantt chart. This is timeline, which is summary of our complete project. Here we have a toolbar with various tools. Let's begin with how to identify our critical path using Microsoft Excel. So I have used that same example in our CPM session. Here you can see activity A to P. Then there is duration, which I have given here in number of days. So A was having duration of 4 weeks. Here 4 into 7, 28 days. To save our time, I have already arranged all these activities with their respective duration. Now let's see how to arrange activities with respect to their predecessors. For C, predecessor is B. Here in Microsoft projects, input is given by activity number. So as you can see, for C, predecessor is B, but B lies on second. B is second activity. So here you need to type as 2. Okay. Next is D, and for D, A is predecessor, which is activity 1. For E, predecessor is C, which is third activity. So we will give here 3. Similarly, I have entered predecessors for other activities as given in our table. Here you can see a Gantt chart is automatically generated as per given input. So this is same network diagram as which we have seen in our previous slides. Now we need to determine our critical activities. For that, what we will do is go to Format tab and click on Critical Tasks. So you can see here all these tasks converted into red or pink color are critical path, like activity A, activity D, then activity G. All these activities form a critical path. These are those activities with zero float, and if delayed, they can tremendously hamper our complete project timeline. So this is how you can identify your critical path by using Microsoft projects. Thanks for being here. I hope you enjoyed this tutorial. Stay tuned for more videos on operations management.